Today we will going to see some practice questions from the topic classification and periodicity of elements. This is part 1. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is our index slides. We will going to see the practice questions from question number 1 to question number 8. Let's start with the question number 1. The period number in the long form of periodic table is equal to. Your options are magnetic quantum number of any element of the period, atomic number of any element of the period, maximum principal quantum number of any element of the period, or maximum azimuthal quantum number of any element of the period. So you have 10 seconds to solve this question. After that, we will see the correct answer. Okay. Let's see. The correct answer is option C, maximum principal quantum number of any element of the period. So we've asked that period number in the long form of periodic table is equal to. So in a periodic table, the period number will be equal to. This was the question, and the answer is that since each period starts with the filling of electrons in a new principal quantum number, therefore, the period number in the long form of periodic table refers to the maximum principal quantum number of any element in the period. Okay, so period basically is from left to right if you go in a periodic table. If you see in a periodic table, the period is from left to right, the group is from top to bottom. Okay, so in a period, the periodic number refers to the maximum principal quantum number of any element in that particular period. Period number is equals to maximum n of any element. Okay, so n is the principal quantum number and thus our C option is the correct answer. Okay, let's move to the next question, question number 2. Which pair of atomic number of elements has same chemical properties? So we have given some atomic number pairs of elements and we have to find that which pair denotes the same chemical property of the elements. Okay, so options are 13 and 22, 3 and 11, 4 and 24, or 2 and 4. So you have 10 seconds to solve this question. After that, we will see the answer. Let's see, the correct answer is option B, that is 3 and 11. The pair which belongs to the same group, that is, in which both the elements have same outer electronic configuration, has same chemical property. Okay, and we have asked that which atomic number pair has same chemical property. So if it belongs to a same group refers to top to bottom in a periodic table. So if the pair of elements whose atomic number is given belongs to the same group, that means they have the same chemical properties. So 3, if you write the electronic configuration, will be 1s2, 2s1. 11, atomic number, you write the electronic configuration, it will be 1s2, 2s2, 2p6, 3s1. So you can see that outer electronic configuration is same as the last electron is occupying in the s orbital in both the 3 and 11 atomic number of elements. Thus, it will be having same chemical properties and as it's belong to the same group. Thus, option B is the correct answer. Now let's move to the next question. Question number 3. Both lithium and magnesium display several similar properties due to the diagonal relationship. However, the one which is incorrect is. So we have given that lithium and magnesium display similar properties. Why? Because they're diagonally similar. Okay, diagonal relationship. They have diagonal relationship. However, the one which is incorrect among the option will be. Options are both form basic carbonates, both form soluble bicarbonates, both form nitrites, or nitrates of both lithium and magnesium yield NO2 and O2 on heating. You have 10 seconds to solve this question. After that, we will see the correct answer. Let's see. The correct answer is option A, that is both form basic carbonates. So magnesium can form basic carbonate while lithium cannot. Okay. Lithium forms only the normal carbonate like Li2O3, like the other alkali metals which belongs to the lithium, which belongs to the same group of which lithium belongs. Okay. So that's why magnesium can form only the basic carbonate while lithium cannot. So this will be the reaction that 5 Mg plus 6 CO3 2 minus plus 7 H2O giving us 4 Mg CO3 dot MgOH whole twice dot 5 H2O plus 2 HCO3. Okay, here this will be dot. No, this is fine. Yeah. So this will be the reaction for the formation of the carbonate, basic carbonate of magnesium, while lithium forms the simple carbonate like Li2O3. Okay. So this option, that is option A, is the correct answer because this statement both form basic carbonates is incorrect, and we have to find out the incorrect one. Okay, thus our A option is the correct answer. Okay, let's move to the next question. Question number 4. Atomic radii of fluorine and neon in angstrom are respectively given by. So we have to find out the atomic radii of fluorine and neon in angstrom units given in the option. So options are 0.72 and 1.60, 1.60 and 1.60, 0.72 and 0.72, or none of these. You have 10 seconds to solve this question. After that, we will see the correct answer. See, the correct answer is option A, that is 0.72 and 1.60. So atomic radii of neon, which is 1.6, being van der Waals radius, is higher than the fluorine, that is 0.7, which is in fact covalent radius. Okay, so we that neon, in the neon we see the van der Waals forces, due to which we can say that van der Waals radius, and in the fluorine the covalent radius is present. So neon is an inert gas. We all know that neon belongs to the gases which is inert. All the orbital are completely filled, and hence the inter-electronic repulsion is maximum. Okay, so neon is an inert gas, okay, and completely filled, and hence the inter-electronic repulsion is maximum. So inter-electronic repulsion is maximum because it is inert. All the orbitals are completely filled. So if every the electron, they have the inter-electronic repulsion among them because they have the similar charges. That's why the atomic radii of neon 1.6 will be higher than the fluorine 0.72. Okay, and thus option A is the correct answer. Okay, let's move to the next question. Question number 5. Which one of following ions has highest value of ionic radius? Options are lithium positive, bromine 3 positive, boron 3 positive, fluorine negative, or oxygen 2 negative. You have 10 seconds to solve this question. After that, we will see the correct answer. Let's see. The correct answer is option D, that is oxygen 2 negative. So the ionic radii of cation is anion having a positive charge on it. Okay, is known as cation. So the ionic radii of cation is smaller than its parent atom. This is a important concept, that for the cation, the ionic radii is smaller than the parent atom, while the size of anion is larger than its parent atom. Okay, anion is ion having negative charge on it. So size of ions is larger than the parent atom, but the size of cation is smaller than the parent atom. So greater the negative charge on the ion, larger is its radii. Okay. So first we see that cation has a positive charge, so it is smaller than parent atom. And anion has negative charge, it is larger than the parent atom. Okay. But if we compare two anions, so higher the greater the negative charge on the ion present, larger will be its radii. This is the direct relationship. Hence, oxygen 2 negative has highest value of ionic radius from the given option because it has 2 negative charge. That means it is first ion and it is having 2 negative charge. Okay, 2 negative charges. That's why the greater the negative charge, the larger is its radii, and the option D is the correct answer. Okay, let's move to the next question. Question number 6. Which of following series of elements have nearly the same atomic radii? So we have given the series of elements in the options, and we have to find the series which is of nearly same atomic radii. Okay. Options are fluorine, chlorine, bromine, iodine, sodium, potassium, rubidium, cesium, lithium, beryllium, boron, carbon, or iron, cobalt, nickel, copper. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay. Let's see. The correct answer is option D, that is iron, cobalt, nickel, copper. So the atomic and ionic radii of a transition element, which is important. The atomic and ionic radii of transition elements in a given series show a decreasing trend. Okay. For first 5 elements. The transition element is that one D block elements like candium, titanium, okay, vanadium, chromium. So this series is the transition element series. So it is saying that atomic and ionic radii of the transition elements in a given series show a decreasing trend for the first 5 elements only, and then the ionic radii or atomic radii becomes almost constant for the next 5 elements. Okay, so it is a trend, it is a normal trend which is shown by the transition elements, and first 5 elements show a decreasing trend of atomic and ionic radii, and then after that it becomes almost constant for the next 5 elements. And these are the elements from those 5 elements which is having almost constant atomic radii from the transition element series, and thus D option is the correct answer. Okay, let's move to the next question. Question number 7. Chloride ion and potassium ion are isoelectronic. Then which is true among from the options? Options are their sizes are same. Chloride ion is bigger than potassium ion. Potassium ion is relatively bigger, or their sizes depend on other cation and anion. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay. Let's see, the correct answer is option B, that is chloride ion is bigger than the potassium. So we have given that chloride and potassium ion are isoelectronic. So isoelectronic species, in those species, an ion having negative charge is larger in size than the cation having positive charge. Okay, as the magnitude of positive charge, as the magnitude of positive nuclear charge increases, the force of attraction by the nucleus on the electron increases, right? As nuclear charge increases, nucleus will attract the electrons more and more. So the force of attraction by the nucleus on the electrons increase, and hence ionic radius decreases due to the higher positive nuclear charge. Therefore, chloride ion is bigger than the potassium ion. Okay, thus our B option is the correct answer. Okay, let's move to the next question. Question number 8. The ions O2 negative, F negative, Na positive, Mg2 positive, and aluminium 3 positive are isoelectronic. Their ionic radii show which property from the option. Options are an increase from oxygen 2 negative to fluorine negative, and then decrease from sodium positive to aluminium 3 positive. A decrease from oxygen 2 negative to fluorine negative, and then increase from sodium positive to aluminium 3 positive. A significant increase from oxygen 2 negative to aluminium 3 positive, or a significant decrease from oxygen 2 negative to aluminium 3 positive. You have 10 seconds to solve this question. After that, we will see the answer. Let's see, the correct answer is option B, that is a significant decrease from oxygen 2 negative to aluminium 3 positive. So, ionic radii is inversely related to Z, that is atomic number, for isoelectronic ion. Okay. Thus, if you see the atomic number, you can tell the ionic radii order. So the order will be this, that for O2 negative it is most, then F negative, then Na positive, then Mg2 positive, and then least is for aluminium 3 positive. You can see the atomic number aluminium is having 13, magnesium 12, sodium 11, fluorine 9, oxygen. Okay, as ionic radii is inversely related to the Z, that is atomic number. So higher the atomic number, lower is the ionic radii, and you can see the trend and the atomic number here. Okay, thus we can say that a significant decrease from oxygen 2 negative to aluminium 3 positive is observed for the ionic radii, and thus D option is the correct answer. Thank you.